DNP3 Basics, Lesson 12, Other Application Functions. Well, good news and bad news. The good news is that this is the last lesson of the class before the summary. The bad news is that it is the longest. Most of the presentation so far has talked about the basic DNP3 message structure for reading input objects and controlling output objects. There are a few other functions, still part of the subset levels, that do not read points or issue controls. These are time synchronization, clearing an outstation's restart flag, assigning points to classes, enable, disable unsolicited reporting, and cold restart. We will talk about these one at a time. First, time synchronization. Time synchronization is the process where an outstation sets its clock based on information sent from the master in a set of DNP3 messages. Not all systems perform time synchronization, and not all perform it at the same frequency or the same way. For systems that do use DNP3 protocol for time synchronization, the master can synchronize the outstation periodically when the outstation requests time synchronization and after the master or outstation restarts. Masters are supposed to synchronize to UTC time, not local time. For this class, the term synchronized means the outstation considers the clock to be accurate to within system requirements. Unsynchronized means the accuracy is outside system requirements or completely unknown. There is no DNP3 definition for accurate to within system requirements. Once synchronized, the outstation clock may drift. When the accumulated drift gets close to the point where the clock's accuracy is about to enter the unsynchronized range, the outstation, hopefully, sets the need time internal indication. This tells the master to start a new time synchronization sequence. Some outstations may not set the need time indication until the accuracy has exceeded system requirements. The master should periodically synchronize these outstations before waiting for a need time response. DNP3 does not clarify if the need time flag is set when the clock is unsynchronized or when it is getting close to being unsynchronized. There is one synchronization method recommended for serial communication. There is a second method recommended for LAN communication. There is a claim that synchronization cannot occur accurately over a WAN because of possible random delays that could be introduced by network equipment. In reality, the serial method works well enough over a LAN. If time synchronization is required over a WAN, only the serial method will work. And it might work well. Check with the master vendor to find out what method is used for each case. Let's talk about serial time synchronization first. This method uses two messages, delay measurement and write time. The purpose of the delay measurement is to determine how long it takes from the time a message is sent by the master to when it is received at the outstation. This may include several factors such as baud rate and modem startup time if a modem is used. Logic assumes that the delay in sending a message from the master to the outstation is the same as the delay in sending a response from the outstation back to the master. The delay measurement message from the master uses the delay measurement application function code 23 and no objects. The outstation response contains a single object with its internal processing delay. That is, how long it took to receive and process the message and send a response. The master analyzes the sequence and sends a write time message to the outstation that contains a time adjusted for when the outstation will receive the message. This allows the outstation to set its time without concern over communication delays. The master's write time message uses the write application function code 2 with a time object. The time value uses the standard DNP3 6-octet time format, specifying the time in milliseconds since midnight, January 1st, 1970. There is a separate procedure for time synchronization over a LAN. To be honest, this procedure may be slightly more accurate than the serial procedure, but using the serial procedure over a LAN is accurate enough. It is at least as accurate as over a serial line. So, while there is a separate policy for LANs, if your master and outstation use the serial time sync procedure over a LAN, it is really okay. In the LAN time sync procedure, the master sends two messages. The first is record current time. The record current time application function has no objects. The outstation records the time of its internal clock when the message is received. As we see, the function code for record current time is 24. The record current time message is followed with a write current time. Write current time uses a time and date object, variation 3, with the time when the prior record current time message was sent. The outstation sets its clock to this time plus the time that has elapsed since the record current time message was received. The write time message format is the same as for serial time synchronization, except that the variation is 3 instead of 1. As shown, DNP3 defines how the time synchronization process works. However, there are many questions unanswered. If any of the following are important to your system, you should check with the device manufacturer to see how it is done. For masters, does it sync outstations to local time or UTC? UTC is required, but I bet it's not always done. What time synchronization method is used for LAN devices? What time synchronization method, if any, is used for WAN devices? For outstations, what determines when a clock is unsynchronized? Does it set the need time internal indication when the clock is unsynchronized, or does it give the master time to resync beforehand? Are binary events declared when the clock is unsynchronized, stored and sent with a relative time and an unsynchronized time base? Does the outstation have a local clock source, like a GPS receiver, that can permanently maintain desired clock accuracy? If so, what does the outstation do when it receives a DNP3 time synchronization request? And when synchronized from the GPS receiver, does it set its internal clock to local time or UTC? So that ends our discussion on time synchronization. We're on to the next function, which is clearing an outstation's restart flag. When the master sees an outstation response with the restart internal indication flag set, it performs whatever steps are necessary to initialize the outstation. But the first step is always to write 0 to the restart internal indication flag. This flag is in bit position 7 in the first internal indication octet, which makes it point index 7. While DNP3 protocol has many ways to specify index 7 in a write, there is only one way allowed by the subset definitions to reference internal indication index 7. That way is to use a start-stop qualifier, 0 or 1, with both a start and stop index of 7. An outstation is not required to support any other syntax, no matter how logical and alternative it might be. The value for the application function code write is 2. Three of the other additional messages deal with unsolicited reporting. These are assign class, enable unsolicited, and disable unsolicited. Technically, only subset level 3 devices are required to support unsolicited reporting. So, again, technically, these three application functions are only part of subset level 3. Lower level subsets may implement unsolicited reporting. If they do, they must support these functions. All I'm going to say about these functions is that assign class allows points to be assigned to classes 1, 2, 3, or 0, overriding outstation configuration defaults. Enable unsolicited tells the outstation to enable unsolicited reporting for all or a subset of classes 1, 2, and 3. The body of the message contains a list of which classes to enable. Disable unsolicited tells the outstation to disable unsolicited reporting. Here is an example for the enable unsolicited message exchange. The master sends a request to enable unsolicited reporting with object headers for classes 1, 2, and 3. This looks a lot like a read for these classes, except that the application function code is 20 for enable unsolicited instead of 1 for read. The outstation sends a null response, one with no object data, to tell the master that it received and processed the request. If it hadn't processed the request, the response would have had an error flag set in the internal indication field. The last one of these special messages to talk about is code restart. This tells the outstation to restart operation, which is somewhat similar to, or perhaps identical to, rebooting the device. The master request contains only the function code. The outstation response contains a time object telling the master how long the restart operation will take to complete. The master should assume the outstation will be inaccessible for this period of time. The restart operation and time begins as soon as the response message is sent. Thus, we get to the end of the final lesson, which did not take as long as I thought it would. What did we learn here? There are two different types of time synchronization messages, one for land and one for serial. Time synchronization is required unless the outstation has a different reliable time source or if time tagged information is not needed. The outstation tells the master when time synchronization is needed via an internal indication flag. This flag may be set just before the outstation needs to be synchronized or possibly just after. A clear restart internal indication write command should be sent by the master whenever the outstation indicates it has restarted. This should be immediately followed by a complete sequence of startup messages. And there are a few extra messages that are part of the subset. It is important to be able to recognize them when they appear.